below the surface of every ocean on Earth, something is quietly, relentlessly changing. For more than 200 years, since the Industrial Revolution began, humanity has been releasing carbon dioxide into the atmosphere. The ocean, vast, patient, and ancient, has been absorbing it. Every day, the world's seas take in roughly 22 million tons of CO2 from the air above them. Scientists call the ocean a great carbon sponge. For a time, this seemed like a gift. Less carbon in the atmosphere meant a slower warming planet. But the ocean has been paying a price measured in chemistry, a price measured in life. When carbon dioxide dissolves into seawater, it triggers a chain of chemical reactions. CO2 combines with water to form carbonic acid, releasing hydrogen ions into the sea. More hydrogen ions mean greater acidity, and that acidity devours something precious: carbonate ions. Carbonate ions are the building blocks of shells and skeletons across the ocean. Oysters, clams, lobsters, sea urchins, coral reefs, they all depend on carbonate to survive. Since the industrial era began, the pH of surface ocean waters has fallen by 0.1 units. That sounds small, but the pH scale is logarithmic. That drop represents a 30% increase in ocean acidity, more dramatic than anything the ocean has experienced in at least 2 million years. And it is accelerating. Scientists have called ocean acidification climate change's evil twin, and perhaps most hauntingly, osteoporosis of the sea. Because just as that disease weakens bones from within, ocean acidification eats away at the foundations of marine life. Coral reefs, ecosystems sheltering 25% of all marine species, struggle to grow, and in the most acidified waters begin to dissolve. A tiny sea snail known as the pteropod, barely the size of a pea, yet a vital food source for salmon and whales, has already had its shell dissolving in waters off the Southern Ocean. Fish larvae lose the ability to detect predators. Sea urchin young fail to develop. In laboratories, harmful algal species bloom faster and produce more toxins in acidified water, a warning that could ripple through the food chain to dinner tables worldwide. Today, more than 1 billion people rely on the ocean as their primary source of protein. Hundreds of millions more depend on it for their livelihoods. In 2023, 15 governments and the European Union, united under the OSPAR Commission, published their first-ever assessment of ocean acidification across the Northeast Atlantic, drawing on the work of more than 400 scientists. Their findings were unambiguous. Acidification has now been observed in every region of the Northeast Atlantic, from the Arctic to the Greater North Sea, the Celtic Seas, the Bay of Biscay, and deep into the wider Atlantic. Under higher emission scenarios, acidification is projected to accelerate toward the end of this century. Parts of the seafloor itself may become corrosive to the shelled creatures that live upon it. Cold-water coral reefs along the shelf slopes of Europe are among the most vulnerable ecosystems of all. The story of ocean acidification is not yet over, and that matters. This crisis has a clear primary driver: carbon dioxide from burning fossil fuels, which means it has a clear solution: reducing those emissions rapidly and at scale. Monitoring networks are expanding. Early warning systems are already helping oyster farmers adapt, but scientists are clear these tools can assist. They cannot replace the fundamental work of cutting emissions. The ocean has carried our burden long enough. For 200 years, it has absorbed the consequences of human industry, buffering our climate, feeding our civilizations. The question now is whether we will act with the same generosity toward it. The ocean does not speak, but in its chemistry, in the thinning shells of its creatures, in the bleaching of its reefs, it is telling us everything we need to know. It is time to listen.